All right, section 6, called compound inequalities, and or. Basically, we're going to take the inequalities that we did in section 1, 2, 3, and 4, and now we're going to put two of them together. It's called a compound inequality. An inequality that consists of two distinct inequalities joined by the word and or. The word and contains the overlap of the graphs of the two inequalities. Okay? The overlap. This is where we're gonna see what that means. Then we have the word or. It contains each graph of the two inequalities. Okay? So let's look at an example. Okay? The word and. Okay, so we're comparing this. We have x is greater than or equal to 3, and x is less than or equal to 7. So what we're looking for is we're looking for the answers that make both inequalities true. We want to find the numbers that make both of them true. Okay, so if we look at the graph of the first one, we have a closed circle shading right. If we look at the graph of the second one, we have a closed circle shading left. So do you notice that the number 3 and the number 7 and everything in between are shaded both red and blue? So that is the answer. The answer is going to be the overlap of the two pictures. Okay? So the answers are anything from 3 to 7. Those are the solutions that we're looking for. Okay? You can take this compound inequality and you can rewrite it together. Notice right over here on this side, x is greater than or equal to 3. That's the first part. And then on this side, x is less than or equal to 7. Okay, so we have a compound inequality using the word and. Okay, now look at or. Remember, it's both of them. Okay, it contains each graph. So we have x is less than -2, or x is greater than or equal to 1. So we're looking to find all of the answers that make either of them true. Okay, either of them. For and, it was both. For or, it doesn't have to be both. Okay, so we have open circle shading left, closed circle shading right. We don't have any overlap. That's not what we're looking for. So therefore we draw both graphs together on the same number line. There is no short way to write this. You have to write it out as the two parts. Okay, let's see how this works. Okay, so write compound inequality. What compound inequality represents the phrase? And then graph it. All real numbers that are greater than or equal to -4 and less than 6. So greater than or equal to 4. So let's call this n. Greater than or equal to -4. This one is less than 6. So n is less than 6. Okay? So if we look at this graph, I'm doing this to save time. You're not doing this. Okay, did you hear that? I hope so. Okay, so this one is going to be a filled in circle shading to the right. This one is going to be an open circle shading to the left. So the answer will be this and everything in between. so any of these numbers from -4 all the way up to just before 6, because look, it's an open circle, so it doesn't mean it's part of the answer. Okay, so that is the and. All real numbers that are less than or equal to 2.5 and greater than 6. So the numbers that are less than or equal to 2.5 and greater than 6. The numbers that are greater than 6. Okay. Less than 2.5 or greater than 6. So when we look at this one, sorry, it's supposed to be an or. Okay, it's supposed to be an or. All right, so we've got the numbers that are less than or equal to 2.5 and the numbers that are greater than 6. So we go through the process. We've got 2 and 3. We've got 6. Okay, so this one less than or equal to 2.5. And then we have this one greater than or equal to greater than 6. So that would be our answer. Anything in this shaded region and anything in this shaded region makes only one of them true, and that's what's important. Now, I know that this was a mistake, but if this said and, if it did say and, do you see how there's no overlap? There is no overlap, so therefore there would be no answer. It would be the empty set. There are no solutions if this is an and, because this one's going in that direction, this one's going in the other direction. There's no doubling over. There's no shaded region for both of them, so there would be no answer. Okay, then we have solving these, right? So they combine this. Now, it is possible to solve it this way. Okay. That's up to you if you want to do it. I would just add 4. But remember, we have 3 sides, so I have to add it to all 3 parts. So what I get is 2 is less than 3y is less than 18. And then I divide everything by 3. So I get 2/3 less than y less than 6. Okay. So that becomes my answer. And then I guess if they want us to graph it, then we would graph it this way. Put a 6 here, 0, 1. We put open circle, everything in between. Remember, when we write it like this, it's always an and. Okay. Now, if you don't want to do it that way, you can always separate. So you go through the process of solve that one, and then you do this one. So we can separate the 2 inequalities. We don't have to do them together if we don't want to. Okay. All right, so that's the first 2. I don't want these things to get too long, so I'm going to make a second video to cover the second half. Okay? See ya.